The journey of landforms and their evolution continues. In Part 3, we'll explore how the powerful forces of wind, waves, and ocean currents continuously shape our planet. Discover the fascinating world of Aeolian landforms created by wind and coastal landforms shaped by waves and currents, from spectacular dunes and mushroom rocks to dramatic sea cliffs, caves, arches, and beaches. Let's explore the forces that shape Earth's ever-changing landscapes. Winds, Aeolian landforms. Aeolian processes involve erosion, transportation, and deposition of sediment by the wind. These processes occur in a variety of environments, including the coastal zone, cold and hot deserts, and agricultural fields. Common features of these environments are a sparse or non-existent vegetation cover, a supply of fine sediment, clay, silt, and sand, and strong winds. Aeolian processes are responsible for the emission and/or mobilization of dust and the formation of areas of dunes. They largely depend on other geologic agents, such as rivers, glaciers, and waves, to supply sediment for transport. The term Aeolian comes from Aeolus, the Greek god of winds. In India, Aeolian activity is most visible in the Thar Desert of Rajasthan, covering about 200,000 square kilometers of area. Aeolian processes involve erosion, transportation, and deposition of sediment by the wind. The erosion by the wind is caused by the processes corrasion or abrasion. Corrasion is a term for the process of mechanical erosion of rocks by the forceful action of the wind, which carries small particles. Such action of the wind causes the grooving, scarring, polishing, and grinding of rocks. The intensity of corrosion depends on the size and density of the carrying materials and the surface rocks. If rocks are soft, corrosion is greater. Attrition. It is the process where pieces of rock are transported through wind or water and wear down the bedrock and surroundings as a result of friction. Gravel or other small stones are often carried through a current and then come into contact with the sides and bottom surfaces. As rocks are transported, the regular impacts between the grains themselves and between the grains and the bed cause them to be broken up into smaller fragments. Corrosion. Corrosion is a process of chemical erosion. Rocks or stones can be eroded as water gets into cracks and holes and dissolves the rock through. Erosional features produced by wind. Here are the major erosional landforms created by wind, Aeolian erosional landforms, along with examples of each. Deflation. Hollows, blowouts. Shallow depressions formed when wind removes loose sand, dust, and other fine particles from the surface. Example, deflation hollows are common in the Sahara Desert, Africa. Mushroom rocks, rock pedestals. Rocks with a narrow base and a broader upper portion. They form because wind-blown sand causes stronger abrasion near the ground. Example, mushroom-shaped rocks can be seen in the White Desert, Egypt. Yardangs. Long, narrow ridges carved by strong, persistent winds. They are generally aligned in the direction of the prevailing wind. Example, the Lut Desert, Dasht-e Lut, Iran, contains spectacular Yardang formations. Zoygas. Table-like rock formations produced by differential erosion, where softer rock layers are worn away faster than harder layers. Example, zoygas are found in the Sahara Desert, particularly in Algeria and other North African desert regions. Ventifacts. Individual rocks that have been polished, grooved, or shaped into flat faces by wind-blown sand. Example, ventifacts are found in the Atacama Desert, Chile, and other arid regions. Desert pavement, redge. A stony surface left behind after wind removes finer particles such as sand and dust, exposing closely packed pebbles and stones. Example, extensive desert pavements occur in the Mojave Desert, USA. Rock arches and natural openings. In some arid landscapes, wind abrasion, together with weathering, can help enlarge openings and shape arches in rock. Example, Arches National Park, Utah, USA, has many famous natural rock arches. Major depositional landforms of wind, Aeolian landforms, with examples. Wind deposits material when its speed decreases and it loses the ability to carry sand, silt, and dust. The major depositional landforms are sand dunes, mounds or ridges of sand formed by the deposition of wind-blown sand. Examples: Sahara Desert, Africa; Thar Desert, India; Namib Desert, Namibia. Major types of sand dunes: Barkhan dunes, crescent-shaped dunes with horns pointing in the direction of the prevailing wind. Example: Thar Desert, India. Transverse dunes, long ridges of sand formed perpendicular to the prevailing wind direction. Example: Sahara Desert, Africa. Longitudinal, safe dunes, long, narrow ridges generally aligned parallel to the prevailing wind. Example: Namib Desert, Namibia. Parabolic dunes, U-shaped dunes, often partly stabilized by vegetation, with their arms pointing upwind. Example: coastal areas of the Netherlands and the Great Lakes region, USA. Star dunes, large dunes with several arms radiating from a central peak, formed where winds blow from multiple directions. Example: Badane Desert, China. Loess, extensive deposits of fine, wind-blown silt. Loess soils are often highly fertile. Examples: Loess Plateau, China; Mississippi River Valley, USA; European Loess Belt. Sand sheets, broad, relatively flat or gently undulating layers of sand deposited by wind. Examples: Sahara Desert, Africa; Arabian Desert. Sand ripples, small, wave-like ridges formed when wind sorts and deposits sand grains. Example: common in the Namib Desert, Namibia, and the Thar Desert, India. Nebkas, vegetation dunes, small mounds of sand that accumulate around shrubs, grasses, or other obstacles. Examples: Taklamakan Desert, China; arid regions of Central Asia. Waves and currents, coastal landforms. Coastal landforms are natural features shaped at the boundary where land meets sea through continuous interaction of waves, tides, currents, winds, and geological structure. These landforms evolve rapidly compared to continental features because marine processes operate daily and intensify during storms and high tides. Waves generated by wind energy act as the most powerful agent, constantly modifying coastlines through erosion, transportation, and deposition of sediments. How waves and currents shape the coast. Erosion. Waves smash against the shore and break down rocks using hydraulic action, water pressure trapping air in cracks. Abrasion, rocks scraping against the cliff, and chemical dissolution. Transportation. Currents move the loosened sand, pebbles, and sediment along the shoreline. Longshore currents move sand sideways parallel to the beach. Deposition. When waves and currents lose energy, they drop their carried sediment in calmer areas, building up new landforms. Major marine erosional landforms. Marine or coastal erosional landforms are mainly created by waves, tides, and coastal currents through processes such as hydraulic action, abrasion, attrition, and solution. Sea cliffs. Steep rock faces formed when powerful waves continuously erode the base of a coast. Example: Cliffs of Moher, Ireland. Wave-cut platforms. Broad, gently sloping rocky surfaces left behind as sea cliffs retreat due to continuous wave erosion. Example, wave-cut platforms along the coast of the United Kingdom. Sea caves. Hollows or openings formed when waves erode weak points, cracks, or joints in coastal rocks. Example, Blue Grotto, Malta. Sea arches. Formed when continued wave erosion enlarges a sea cave until it cuts through a headland, creating an arch. Example, Durdle Door, England. Sea stacks. Isolated columns of rock left standing in the sea after the roof of a sea arch collapses. Example, 12 Apostles, Australia. Stumps. Short, eroded remnants of sea stacks that remain after continued wave action reduces the stack. Example, Haystack Rock, Oregon, USA. Blowholes. Vertical openings formed when waves force water and air through cracks or caves in coastal rock, often producing spectacular sprays. Example, Kiama Blowhole, Australia. Headlands and bays. These develop through differential erosion. Softer rocks erode faster to form bays, while harder, more resistant rocks remain projecting into the sea as headlands. Example, Swanage Bay and nearby headlands, England. Major marine depositional landforms. Marine or coastal depositional landforms are formed when waves, tides, and coastal currents lose energy and deposit sediments such as sand, gravel, and silt. Beaches. Accumulations of sand, shingle, pebbles, or other sediments along the shoreline. Example, Copacabana Beach, Brazil. Spits. Long, narrow ridges of sand or shingle attached to the land at one end and extending into the sea. They are mainly formed by longshore drift. Example, Spurn Head, England. Bars. Ridges of sand or shingle deposited across the mouth of a bay, partially or completely enclosing it. Example, Chesil Beach, England. Tombolos. Depositional features that connect an island to the mainland or to another island through a ridge of sand or shingle. Example, St. Ninian's Tombolo, Scotland. Barrier islands. Long, narrow, sandy islands lying parallel to the coast, separated from the mainland by a lagoon or bay. Example, Outer Banks, North Carolina, USA. Lagoons. Shallow bodies of water separated from the open sea by a bar, spit, barrier island, or coral reef. Example, Chilika Lake, India. Cuspate forelands. Triangular or pointed accumulations of sand and shingle projecting outward from the coastline, usually formed where waves approach from different directions. Example, Dungeness, England. Coastal dunes. Mounds or ridges of wind-blown sand deposited just behind beaches and often stabilized by vegetation. Example, Great Sand Dunes, coastal areas, Netherlands. Thus, Earth's surface is never truly static. It is continuously uplifted, weathered, eroded, and reshaped over time.